I'm Nova.
I'm Alloy, and this is AgentStack Daily.
OpenAI's terminal-based coding agent Codex adds Amazon Bedrock as a built-in provider in Release 1.48, alongside session branching with Codex exec fork and asynchronous MCP hooks.
Meanwhile, Google's Gemini 3.7 Flash introduces native hybrid reasoning across a 1 million token multimodal context, letting builders configure thinking budgets from 0 up to 64,000 tokens at flash speed and pricing.
Today, we're diving deep into Gemini 3.7 Flash hybrid reasoning, Codex 1.48, Z.Ari's GLM 5.3, local testing with Qwen 3.827b, and a trilingual agent roadmap.
Plus world models that switch goals without retraining, advertising inside ChatGPT, and why smarter decoding beats raw model scale.
OpenAI shipped 0.148 of its terminal-based coding agent Codex on August 18, and Amazon Bedrock is now a built-in model provider. Codex can use an AWS profile and region to reach models hosted through Bedrock, with GPT 5.6 routing supported out of the box. That matters inside enterprise environments where IAM roles, billing accounts, model access, and corporate compliance already run through AWS. Those engineering teams no longer need to maintain an isolated model proxy just to keep inference inside their established cloud boundary. The other big addition is Codex exec fork. It branches an existing session into a separate run, preserving useful context while allowing the new path to proceed independently. A developer investigating two possible fixes can split the conversation cleanly instead of flattening both approaches into one confused thread. The terminal resume picker also gains archive and restore controls, while the export command can copy a complete conversation as Markdown or write it to a new file. A coding agent session can finally behave more like a working document, branchable, portable, recoverable, shareable, and inspectable across teams. Cost visibility lands in the status command, configurable status lines, and the terminal title bar, where eligible workspaces can display estimated thread credits or dollar cost directly beside active terminal output.
Honestly, the asynchronous hook work may age even better. External scripts can now run without blocking the main turn, and those scripts can invoke MCP tools directly. MCP is the standard connection layer agents use to call outside tools and data sources. A hook can start a build, query a database, execute a build pipeline, or trigger another external service while Codex continues working on its current turn. OpenAI also repaired failures that become painful during long sessions. Changing models no longer leaves stale configuration instructions behind or swaps the underlying model halfway through an active turn. Resumed sessions reliably restore their saved working directory and execution approval policy. A turn can reconnect after a temporary provider outage, and an MCP server can recover after account reauthentication without forcing a Codex restart. The terminal interface now rejects buffered input that could accidentally activate a prompt, handles Windows-style line endings and wrapped whitespace more cleanly, and renders long links without mangling the transcript. Sandbox handling fails closed when a path is denied or unreadable on Linux and Windows.
Google's Gemini 3.7 Flash represents a significant architectural shift by introducing hybrid reasoning into a single unified model. Rather than forcing developers to choose between a fast standard model or an expensive reasoning model, Gemini 3.7 Flash unifies both. Developers configure a thinking budget per API call from 0 for instant sub-second tool execution up to 64,000 tokens for deep multi-step code exploration. It maintains full multimodal capabilities across text, code, audio, video, and imagery in its 1 million token window.
Exactly. And how it stacks up against the competition is where it gets compelling. Claude 3.7 Sonnet also offers hybrid thinking, but at frontier pricing, $3 per million input and $15 per million output. Gemini 3.7 Flash delivers comparable SWE bench verified coding performance at Flash tier pricing, roughly 10 to 35 cents per million tokens. That changes the economics completely for autonomous coding agent loops where an agent executes dozens of exploratory tool calls and file inspections per task.
Compared to OpenAI's O3 Mini and O1, which use fixed reasoning tiers and lack native video or audio input, Gemini 3.7 Flash gives continuous thinking control with full multimodal processing across its entire million-token window. And against text-only entries like GLM 5.3 or quantized models like Qwen 3.827b, Gemini 3.7 Flash delivers immediate sub-second time to first token without sacrificing deep planning or architectural comprehension.
For agent builders, the clear pattern is dynamic thinking allocation, run routine classification and tool calls with zero thinking tokens, and dial the budget up to 4 or 16,000 tokens for complex refactoring, compiler diagnostics, and bug investigation.
Z.AI describes GLM 5.3 as a large-scale reasoning model for complex software engineering and long-horizon agent work. It's available through OpenRouter with text input and text output, a 1 million token context window, and a 4096 token output ceiling. The context can hold a large repository, extended tool history, design documents, and a substantial working conversation together. The output ceiling is much tighter, so the model can read vastly more than it can return in one response. That distinction matters. A million token context doesn't mean a million token answer, and it doesn't prove the model can reliably use every detail it receives. Still, it gives routing systems another option for jobs that outgrow smaller windows. A coding agent could preserve more of a long investigation without constantly compressing earlier work, while a repository assistant could ingest broader portions of a codebase before deciding where to look. For developers handling large refactoring traces, that extra headroom prevents sudden context truncation.
That's exciting, with an asterisk the size of the context window. Long horizon work depends on coherence, planning, tool use, latency, and cost, not just how much text fits through the door. GLM 5.3's listing doesn't disclose active or total parameter counts, and it exposes no image or audio modality. It's a text reasoning model, not a universal multimodal system. The credible advantage will emerge if independent agent evaluations show it retrieving the right evidence from deep inside that million token input and keeping a plan intact across many actions. Pricing and rate limits will also decide whether teams reserve it for unusually large jobs or route ordinary coding work there. Longer prompts can introduce irrelevant or contradictory context, so prompt hygiene still matters even when compression becomes less urgent. Z.AI has opened a genuinely interesting long context lane. It hasn't made context management disappear.
Alibaba's Qwen Research Lab released Qwen 3.827b under the Apache 2 license, with vision input, 27 billion parameters, and a native context window of 262,000 tokens. That puts a multimodal model within reach of local workstations. Qwen's benchmarks claim it improves on Qwen 3.627b and the closed-weight Qwen 3.7+, though independent validation is still pending.
Simon Willison's hands-on result is more immediately useful. He ran a 17GB, 4-bit quantized build through LM Studio on a MacBook Pro with 128GB of memory and on an NVIDIA DGX Spark. He also used a Llama server runtime on the Spark. The model worked, but it arrived with reasoning effort set to extra high. On ordinary prompts, it kept consuming every available token while thinking about work that didn't justify it.
Which is a very Qwen-shaped comedy, smart enough to solve the problem, determined enough to write a private dissertation first. LM Studio's default context made the behavior especially visible because reasoning could fill the available window. Loading the full context removed that immediate squeeze, but it didn't fix the mismatch. Lowering reasoning effort did. Local applications can trade deliberation for responsiveness without replacing the model.
And that control changes where a 27 billion parameter model fits. Vision support makes it relevant to screenshots and image-grounded work. Apache 2 licensing permits broad commercial use, and quantization makes the weights compact enough for high-memory consumer hardware. The open questions are whether independent comparisons confirm Qwen's claimed gains and whether runtimes choose sensible defaults. A local assistant that spends minutes contemplating a routine request can feel worse than a weaker model that answers cleanly. Qwen 3.8 looks unusually capable for its size, but maximum effort isn't always appropriate effort. Setting sensible runtime parameters unlocks its true practical utility. Agent education usually breaks in one of two ways: it's a random pile of links, or it assumes everyone learns technical language most comfortably in English. When you choose Awesome Agentic AI ZH project attacks both problems. The repository organizes more than 240 resources into a path that begins with language model foundations and advances toward agents and multi-agent systems. It presents material in traditional Chinese, English, and simplified Chinese, with hands-on examples alongside the references.
The repository had 5,754 GitHub stars in the verified community figures, received active updates on August 18, and followed a major release dated August 14. Those numbers don't prove every link is excellent, but they show meaningful interest and active maintenance. The sequencing is the useful part. A learner can move from basic model behavior into tool calling, the ability for a model to request an outside action, and then into agent loops, where a system plans, acts, observes the result, and decides what comes next.
Right, and the side-by-side languages solve a subtler problem than access alone. A Chinese-speaking developer can read an explanation in the language that feels natural, compare the English term used in documentation and code, then switch back when the concept becomes dense. Memory, for example, may mean saved facts, retrieved documents, conversation history, or application state. Equivalent explanations can separate the concept from its fashionable English label. That's more valuable than merely translating a menu.
I like the ambition, but curation has an expiration date. Agent frameworks, interfaces, and patterns change quickly, so a roadmap can become a museum if links stop moving. The August update is encouraging because it shows active maintenance. At more than 240 resources, it functions as a practical curriculum. Its lasting value will come from pruning stale material as aggressively as adding new material. OpenAI announced an initiative aimed at strengthening democratic oversight when AI enters defense and intelligence work. The company describes 3 core areas: giving government institutions tools, providing technical training, and supplying expertise that helps them scrutinize national security deployments. AI used by the state can influence surveillance, targeting, intelligence analysis, and other decisions carrying exceptional public consequences, so oversight bodies need enough technical understanding to challenge what vendors and agencies tell them. Technical access alone won't create accountability, either. Reviewers also need independent authority, durable records, audit trails, and a clear operational mechanism to question decisions after deployment rather than only before procurement.
Look, that goal is difficult to argue with. The announcement is also light on commitments that would let outsiders measure it. OpenAI didn't name participating partner agencies, identify specific training cohorts, describe independent access to deployed models, or specify funded oversight pilots. Tools, training, and expertise can mean serious institutional capacity, or polished briefings delivered by the company whose systems are under examination. Democratic oversight becomes credible when legislators, inspectors, technical auditors, and civil society groups can ask hard questions and obtain empirical evidence that isn't controlled entirely by the model supplier. For companies selling into defense or intelligence, the announcement may influence procurement language before it changes deployed technology. Buyers could ask more explicitly who reviews a model, what records survive after it acts, and how an institution contests a consequential output. I'd also want to know whether oversight extends to contractors and downstream systems, because public agencies often buy assembled services rather than one model in isolation. The real test arrives when OpenAI names partners and explains what authority those partners receive. Until then, it's a direction rather than an accountable program. NVIDIA makes the accelerators underneath much of the AI boom. So what's notable about it using ChatGPT work rather than relying entirely on its own internal stack?
OpenAI's customer story says NVIDIA teams use ChatGPT work to reduce manual work, connect fast-moving information, and spread successful workflows across the company. That last part moves the product beyond an individual chat window. If one group turns a recurring job into a reusable workflow, another group can adopt the working pattern instead of rebuilding it from scratch. At a company operating across chips, networking, software, research, sales, and global supply relationships, information changes faster than static internal guides can absorb it. A conversational layer can help people combine those signals and preserve repeatable ways of handling them. It can also give specialists a way to package judgment that colleagues elsewhere can reuse, which is more consequential than merely accelerating one person's writing.
I buy the structural idea, but the evidence is broad. The case study doesn't say which NVIDIA divisions adopted the product first, how many workers use it, or how many hours were saved. Scaling expertise sounds great in a headline but remains difficult to evaluate without data. Still, NVIDIA's adoption says something about enterprise reality. A major chipmaker is using another company's assistant as coordination plumbing. Once workflows travel between teams, questions about ownership and freshness travel with them. Right now, OpenAI has supplied a prominent customer and a plausible operating pattern, illustrating how shared assistants are becoming corporate infrastructure.
Linguistics Olympiad puzzles give contestants examples from an unfamiliar language and ask them to infer the rules. The IOLAI challenge put those puzzles in front of AI systems under a single T4 GPU and a 30-minute limit per problem. The resource-constrained submissions placed in the bottom 5% of human contestants, while Claude Opus 4.8 reached gold medal level performance.
Here's the surprising part: model size alone didn't explain the rankings. Smaller tuned systems beat models several times larger because teams improved decoding, how the system generates, explores, and selects its output.
Right, so buy a bigger model wasn't the winning answer. Automatic scoring followed the human jury's overall order but gave weak systems more credit than the jury did, meaning convenient machine grading softened some failures.
That's a useful correction to the scaling obsession. These puzzles expose whether a model can infer hidden structure rather than retrieve familiar facts. Under tight resources, better output handling delivered more than raw scale. Large models aren't irrelevant, but capacity left unmanaged loses to smarter output exploration.
OpenAI has published its approach to model development as frontier systems gain more meaningful cyber capabilities. The company says monitoring, alignment, and security practices should influence how quickly advanced models move toward release. There's no new model or product attached to the post. It's an explicit statement that capability gains in offensive cybersecurity now affect launch pacing rather than appearing as one more benchmark after a release decision has effectively been locked in.
Pacing is doing a lot of work there. Is OpenAI describing a genuine break, or a safety process that develops alongside a release calendar?
The available summary doesn't name a new evaluation suite, deployment gate, red team program, or threshold that would answer that. It describes safeguards at a general level. But the subject is consequential because a model that helps defenders analyze vulnerabilities can also reduce the expertise and time needed for offensive work. More capable agents may combine reconnaissance, code analysis, tool use, and exploitation attempts across longer tasks. Monitoring can reveal abuse after access begins, alignment tries to shape what the model will assist with, security controls protect the model and surrounding systems. Those are fundamentally different operational jobs. A claim about pacing becomes measurable only when OpenAI explains how empirical evidence from them alters launch schedules. Disclosure also has limits. Publishing every threshold could help adversaries understand where controls begin. Even so, the public can reasonably expect a clearer account of which specific capabilities affect deployment. I'm glad cyber capability is treated as a release variable, but vague language cannot carry the argument alone.
Most learned world models, internal simulations of how an environment changes, entangle perception with reward. Teach an agent to navigate toward a blue key, and changing the target to a red key can require more interaction and another training run.
Researchers propose separating observation reconstruction from reward prediction. The simulation continues learning what the world will do, while reward is calculated from a small set of human-readable symbolic state variables. Change that rule and the learned environment doesn't have to be rebuilt. That enables zero-shot task transfer, repointing an agent toward a new objective without collecting fresh experience first. A simulated robot could pursue a different object, Or a game agent could adopt new scoring, while retaining its learned dynamics and physics. Facts about how the world behaves survive changes in agent goals.
Fair enough, and keeping dynamics separate from reward logic means teams only train the expensive physics simulation once.
Asana says a migration away from an outdated testing system took about 2 weeks with Codex, after its engineering team had estimated the work at roughly 5 years. The reported cost was about $12,000, and the effort involved 2 engineers. That comparison is so extreme it deserves both serious attention and careful skepticism. OpenAI published the customer case, and the 5-year estimate came from Asana. The summary doesn't expose enough technical detail to reconstruct the exact workflow independently.
Still, 5 years to 2 weeks changes a budget conversation even after a heavy discount. What do we actually know about the work?
We know it involved replacing an obsolete testing system and that Asana completed the migration with Codex assistance. We don't know the test suite's full size, the volume of files changed, the exact agent configuration, the proportion of generated code accepted directly, or how much human review and manual repair sat behind the finished result. 5 years may represent a low-priority backlog estimate under normal staffing rather than 5 years of continuous engineering labor. That distinction doesn't erase the result, but it changes the comparison. An agent can make neglected work economically attractive by lowering the cost enough for a small team to begin. And finishing quickly has a second-order benefit. The organization spends less time maintaining both the old and new systems during a prolonged transition.
Honestly, that's wild. Legacy migrations are unusually suitable territory. They contain repetitive transformations, test feedback, and an established destination format. The model translates existing intent while people supervise exceptions. Asana's case suggests coding agents can compress that mechanical burden dramatically. It doesn't mean every 5-year rewrite becomes 2 weeks, but a deprecated subsystem that looked too expensive to touch can now compete for attention. OpenAI's Defenders window argues that AI is reshaping both attackers and defenders. The company says it's strengthening its own defenses and points security teams toward guidance as the threat environment changes. Does the published material identify what actually changed?
Not in the available summary. It doesn't name a new product, model, detection system, control, or measurable mitigation. That makes it a perspective piece, not a changelog. The broad premise is credible. AI can reduce the cost of producing code, analyzing software systems, translating complex technical material, and automating repetitive tasks. Those capabilities can help defenders investigate telemetry alerts and patch software rapidly, while also helping attackers accelerate reconnaissance. But the title promises a window for defenders, and the useful question is what preserves that advantage.
Fair point, but I don't buy the stronger implication yet. Faster remediation, better telemetry, controlled access to powerful capabilities, and stronger security boundaries around AI systems could all contribute. The source summary doesn't establish which of those OpenAI has materially advanced. So the fair reading is directional. OpenAI wants security leaders to assume the threat model is moving and to treat AI as relevant on both sides of an incident. Foregrounding defense may foreshadow upcoming product controls, security certifications, or detection capabilities for enterprise workloads.
It also connects with the pacing argument. One post says rising cyber capability should affect model releases, the other argues defenders have an opportunity to use AI before attackers capture all the gains. The next meaningful evidence would be shipped protections, named detections, measured response improvements, or clear access controls. Without those concrete mechanisms, the defender's window remains an intriguing theoretical opportunity rather than an established technical posture. OpenAI has expanded ChatGPT ads across 31 European markets, moving beyond a limited pilot into a broad regional rollout. The company presents the placements as a way to reach people while they're exploring choices, comparing products, and preparing to make decisions inside ChatGPT. That puts advertising close to conversational intent, the moment a person describes a specific technical or consumer need rather than typing fragmented keywords into a traditional search box.
Well, honestly, that changes the assistant's commercial identity. Consumer AI products are expensive to operate, while subscriptions reach only part of the overall audience. Ads give OpenAI another way to fund compute usage and turn user attention into sustainable revenue. 31 markets also create enough scale for advertisers to treat ChatGPT as a mature media channel rather than a novelty experiment. OpenAI's language around decision moments suggests it wants the value associated with high-intent search advertising, where a person isn't merely browsing but narrowing options. The unresolved issue is whether a conversational recommendation feels fundamentally different once sponsor money can influence what appears nearby. In an interactive chat, the assistant's language naturally feels personal and authoritative. Clear labeling and separation between the model's answer and paid placement therefore matter more than visual housekeeping. If users suspect the answer itself bends toward advertisers, the product spends trust faster than it earns revenue. Europe will make that commercial tension immediately visible across diverse languages, consumer privacy expectations, and regulatory frameworks. The larger industry contest is over where product discovery fundamentally begins. If people ask an assistant which laptop, trip, service, or subscription fits their needs, the commercial gateway shifts away from a page of links. OpenAI now has a real advertising surface in Europe. Whether people accept it depends on preserving the distinction between assistance and persuasion. OpenAI is funding 14 independent research projects to develop actionable policy ideas for what it calls the intelligence age. The grants center on expanding economic opportunity and strengthening society's resilience as AI reshapes work, education, and governance institutions. Instead of publishing one company-authored platform, OpenAI is funding outside teams to develop independent proposals.
Independence deserves careful handling when funding comes from one of the companies most affected by the resulting regulations. Funding outside researchers can broaden the conversation beyond OpenAI's internal policy staff, but it doesn't automatically remove institutional influence or potential conflicts of interest. The initiative's quality will depend on who the 14 teams are, whether they can criticize the sponsor freely, how their work is published, and whether policymakers receive implementable proposals rather than slogans about abundance.
Right, and the timing matters because labor markets don't wait for legislation. AI is already changing which tasks companies automate, which skills they value, and how quickly small teams complete projects. We just heard Asana's striking example. Policy responses could touch education, worker transitions, market competition, income support, regional investment, public services, or the distribution of productivity gains across society.
Here's what I want to see: 14 independent projects producing genuine viewpoint diversity and rigorous analysis rather than clustering around one convenient economic perspective. OpenAI is acting as a backer here, not claiming it has solved the policy questions. That's appropriate. A model company shouldn't get sole authorship over the social contract surrounding its technology. Finished proposals will matter more than the grant count. Financial support can create room for independent thought, while full transparency determines whether the public believes that thinking stayed genuinely independent. 3 repositories stand out on radar today. HKUDS's Nanobot makes its first tracked appearance with 47,165 stars. It's an ultra-lightweight, self-hosted Python agent framework featuring a web interface, extensible tools, persistent memory, MCP connections, multi-agent workflows, and modular chat integrations. Release point 3 shipped July 25, and the repository was updated August 19. Codebase Memory MCP approaches the same ecosystem from another direction. It indexes code into a persistent knowledge graph across 158 languages. It has 39,485 stars after adding 7,818 in 30 days, a 24.7% jump, and release point 10 arrived August 19.
That codebase memory growth is hard to ignore. Nanobot gives an agent a compact operating shell. Codebase memory gives agents a structured way to navigate software without repeatedly stuffing the repository into prompts. FastMCP helps build the servers connecting those surfaces. It has 27,282 stars, up 1,068 over 30 days, and release 3.4 shipped August 10.
Together, they cover the agent, the code knowledge it can query, and the Python tooling used to expose capabilities through MCP. Fast MCP's growth is steadier at 4.1%, while codebase memory is the breakout mover.
In model discovery, Google's Gemini 3.7 Flash and Z.AI's GLM 5.3 headline the cycle. Gemini 3.7 Flash brings hybrid reasoning, configurable thinking tokens up to 64,000, and native multimodality into a 1 million token context window at Flash tier pricing. GLM 5.3 provides a text-only 1 million token context window on OpenRouter for long-horizon software engineering. Both models target repository-scale context, but Gemini gives developers continuous control over the latency-quality trade-off while GLM focuses purely on extended reasoning traces across text.
That distinction is critical for production routing. Gemini 3.7 Flash gives agent loops sub-second latency when thinking is zeroed and deep reasoning when budgeted, while GLM 5.3 offers an alternative for pure text repository workflows that require expansive context. Unslother's Qwen 3.827b GGUF package brings the 27 billion parameter Qwen model into a format widely used by local inference runtimes. It carried 1,874 likes and more than 4.3 million downloads in the published figures. The package is quantized, meaning its numerical weights are compressed to reduce memory use, and it inherits Qwen's Apache 2 license, conversational focus, vision capability, and long context. The attraction is obvious. A modern reasoning model can run on local hardware without sending every prompt to a hosted service.
But there's a concrete catch. Runtime defaults can preserve the model's extra high reasoning setting, producing long internal deliberation even on ordinary work. Local availability gives people control over data and deployment, but responsiveness still depends on quantization, available memory, context size, and reasoning effort. In extra research, New Policy Ideas for the Intelligence Age covers OpenAI's 14 grants to independent teams examining economic opportunity and social resilience. How much memory does your agent actually need? From IBM Research, tackles a different scarcity, retaining useful history without carrying every past detail forever. One asks what institutions should preserve as AI changes the economy, the other asks what an agent should preserve as its work grows.
Meanwhile, GitHub Copilot for JetBrains adds enterprise-managed settings for plugin governance, MCP server access, OpenTelemetry, and permission modes. That connects directly to the memory work. Once assistants retain more context and reach more tools, companies want consistent control over what they can access and what operational records they produce. The policy project then widens the same question: who sets the rules when those systems affect work beyond one company? For the primary sources and details behind everything we covered, look at the show notes at toby.fitnesstech.com.
Keep an eye on what ships, what gets measured, and which enormous claims survive contact with independent evidence.
Thanks for listening to AgentStack Daily. We'll be back soon.